science guy.
What is going on in here? Children, this is an area for learning. Well, as long as you're here today, I guess we can do a little learning about the prostate.
No. That's not what we're learning today.
Well, I guess we can learn about the eye. Alright, children. Well, today we're going to be talking about the anatomy of the eye. Starting on the outermost layer is the sclera. And right here is the cornea. This layer right here, which is the color portion of the eye, is the iris. And right here, the portion that allows light into the eye is the pupil. Next, we're going to move into the inside of the eye. So this right here represents where the posterior cavity is, which holds the vitreous humor. This right here is the lens of the eye. So you can see that the lens actually bounces as well. This layer right here, the red layer in between the sclera and the inside of the eye, is called the choroid. And the very innermost layer is called the retina. So the retina actually contains rods and cones. Now rods detect the absence or presence of light, and cones detect different wavelengths, which allows the eye to detect the different kinds of colors. The blind spot is the only part of the eye that doesn't have rods and cones, and that's because that's where the optic nerve leaves the eye and goes to the brain. Alright kids, now we're going to do an experiment that we designed so that you can try this at home. So what you want to do is you want to start with the paper in your hands, and you want to cover your left eye first and use your right eye to look at the dolphin on the paper. Start with the paper far away and bring it closer to your eye, and eventually you'll find that the triangle disappears. This is where your blind spot is located. Alright, so this is a diagram of what the connections between the eyes and the brain looks like. Here you can see the lateral optic nerves in red, and in the center, the blue and the green are the medial optic nerves. Some of the pathologies that can occur in the eye are blindness, which is when the optic nerve is cut in between here. So the green and red are severed completely, which would cause blindness in the right eye. Bitemporal hemianopia is when the optic chiasm is cut. So if the blue and the green were cut right here, that would cause blindness in this side of the eye and this side of the eye. And homonymous hemiopia is when the optic tract is cut. So an example of this would be when the red and the blue are cut right here, which would cause blindness in the right side of the eye and the right side of the eye. Now remember kids, when you're cutting the optic tract, you're affecting the retina in the eyes. And the retina is what contains the rods and the cones. So if we were to sever this optic tract, which affects the red and the blue portions here, you would lose the ability for the rods and cones here to communicate with the brain. And therefore, this retina allows you to see what's to the left of your field of view. So if you were to cut this optic tract once again, you would lose the ability to see what's to the left. In the same aspect, if you were to cut the optic chiasm, which would affect the green portion of the retina and the blue portion of the retina, you would lose the ability to use your peripheral vision. Therefore, you would lose the ability to see everything over here and everything over here. And this is what your vision would look like if you had homonymous hemiopia. As you notice, the left side of your vision is blacked out. You can only see out of the right side of your eye. This second example of the experiment shows what it would be like if you had bitemporal hemiopia. As you can see, your peripheral is blacked out. You can only see out of the center of your eye. I love my job, but thank goodness those kids are gone. That was a long lesson. It's time for me to relax.